are taping now. Okay, today we are doing the beginning of polar with calculus. The very first day. Remember parametric last week? No, you don't. But remember last week, go back and listen to the video if you have to. We did parametric, where if we want to find dy dx, which is the slope of a parametric curve, it is the dy dt over dx dt. But now we're doing polar. So parametric was with respect to time. Are all the polar graphs with respect to theta? The derivative works the same way. It's the same way. So if I have to define something, because what's going to happen is they're going to give you an equation for the radius. And you have to know, sorry, it didn't work out. Let me reset. So you have to know what x is. X is equal to radius cosine of theta, right? And y is equal to what? Radius sine of theta. And if I want dy dx, it would help if I wrote it right, dy dx, it is equal to the dy d theta, that's a really funky y, over dx d theta. Just like parametric, only now it's in terms of theta, right? Only problem is that's a product. R is with respect to theta also. You're going to be given a function for r that's respect to theta. So when you take its derivative, it's a product rule, and you're just going to write the derivative of r with respect to theta is just dr d theta. You're going to go find it every time, and then it's going to be times, we're doing the y on top, so it's sine theta plus r, and the derivative of sine theta is cosine theta, right? Yes. This is just the generic, every single time is going to be the same. Then on the bottom, for taking the derivative of the x, it's dr d theta cosine of theta minus r sine of theta, because the derivative of cosine is a negative sine. You need to know this. I don't say memorize, because you just need to know it. However you want to do it, I personally don't memorize it. I know what x and y are based on having taken the class and taught geometry and taught pre-cal and taught calculus. I just know those, and from them I can go and find the derivatives really fast because I'm good at product rule. You should get better at it. If you want to memorize it, memorize it. I don't really care. I just need you to know it, because if you don't know it, I'm not going to give it to you. We're literally on your test. I will give you an r equation in terms of theta and a theta value and say go find the slope at that point, and guess what? The slope at that point is a derivative dy dx, right? Wow. Oh wow. So let's do one like that right now. So example 1 is find dy dx, or slope, right? Could I say it either way? If I find the slope, do you have to know it's dy dx? For r equals to 3 plus 2 sine theta at theta equals 2 pi over 6. I want the slope at pi over 6 of that polar graph. So one of the things one of the things you have to do, first you have to write x. So x is equal to r, which is 3 plus 2 sine theta times cosine theta. And then y is equal to 3 plus 2 sine theta times sine theta. And I do the derivative by product rule. You could distribute and take the derivative. I really don't care. There are many ways to get it. You just have to find your way. Okay, one of the first things I would do, actually, before I do that, I would find dr d theta, because I'm going to be using it twice, right? Dr d theta is really easy. Derivative of 3 is 0. Derivative of 2 sine theta is just 2 cosine theta, isn't it? Oh, that was easy.
That was easy. Rien plus simple.
Okay, and then dy dx is equal to dr d theta, which is 2 cosine of theta times sine of theta, plus And then it's going to be r, which is 3 plus 2 sine of theta, times the derivative of y, which is cosine of theta, all over. So all I did at the top was just dy d theta, right? Okay, now I got to do dx d theta. I'm going to get the 2 cosine of theta, sine theta again. But I'm going to do a minus, and then it's 3 plus 2 sine of theta. Derivative of cosine is sine. The reason it's minus is because it's a negative sign. Now, I'm evaluating both of these at a angle equal to pi over 6. So I'm evaluating this at theta equals pi over 6. And that is the correct notation for the AP test. That's how you show you're taking the derivative at a point. You do the bar, and then tell them what value you're evaluating it at. So dy dx evaluated at theta equals to pi over 6 is equal to, well, before we start, I would like to show you some magic. This is a trig identity. That is sine of 2 theta. Would that make it easier to evaluate? Yeah, it's going to combine a lot of stuff. You don't have to multiply it. If you multiply this, so this right here, that would be a sine 2 theta also. And then this one is just 3 cosine of theta. And then this is a sine squared. We're not going to worry about it though. I messed up. This is a sine. Again, I messed up the wrong one. Hang on. This is a cosine. This is a cosine. I realized as I look back here, I was doing sine again. So that's a cosine of theta. And you'll notice that this is a 2 cosine squared theta, and that's a minus 2 sine cosine squared theta. And that was another one, different double angle, but we're not going to worry about that one today. You're going to have to know all those double angle theorems, not the tangent, the sine and the cosine. That's a real thing on this in this unit. I don't feel like simplifying that much for y'all. So on the top, what am I going to do when I put in pi over 6? It's double pi over 6, which is pi over 3, right? So I have sine of pi over 3. And then back here I have another one, so I have 2 of them. Yes? I'm pulling that one up front, and then I have a plus 3 cosine of pi over 3, pi over 6, because I didn't double it. And then in the denominator, I have 2 times cosine of pi over 6, all that squared. And then it's minus, and then if I distribute, it's going to be minus a 3 sine of pi over 6. Oops, don't need that. Minus, and then if I do that, it's going to be a 2 sine of pi over 6, all that squared. Right? So let's see what that gives us. That is going to give us on top, sine of pi over 3 that's square root of 3 over 2. And that's square root of 3 over 2. And this is 3 square root of 3 over 2. Yeah, it is. So together, do we have 5 square root of 3's over 2? So the top becomes 5 square root of 3 over 2. On the bottom, that is a square root of 3 over 2, but it's squared. Does that become 3/4 times a half? Is that? No. 2 times square root of 3 over 4. Okay. Oh, sorry, it's 3. So it's 3 over 4, so it's just 3 halves. Yeah. Sorry, I wasn't good there. I have it written on my paper. I had it a minute ago. I blinked. So it's, oh, sorry. Hang on. So we're dividing by, that whole thing becomes 3 halves. Does everybody see it? Yeah. That becomes 3 halves. This is, that's a half. Is this a minus 3 halves? Do the 3 halves go away? Yes. And then here, that's a half, right? So I have negative 2 over 4. Am I dividing by negative a half? Dividing by negative a half is the same as multiplying by negative 2. And the answer is negative 5 square root of 3. And why did we go through all that? Because they could give you one on the AP test that's multiple choice and you have to simplify it. So y'all should need to practice this. It is a real skill. All right, that's it for notes. Now I'm just going to do your warm down.